All right, so we're doing some populations and samples first. So what is the difference between a population and a sample? Think about population of our country, population of the school. It's a specific group that I want to know more about. Within this unit and throughout second semester, we're looking at different ways to interpret trends in a population without having to ask every single person within a given population, every single person or individual within a given population. So rather than asking every single person in a population, every single person we're interested in knowing more about, we're going to take what's called a sample, make our lives easier, and only poll a specific set of people within that population group. A sample is a subset, a representative subset, a smaller group, a smaller breakdown of a given population. We sample a population. I take a sample of individuals from a population. I have my whole group. Let's just talk about a few of them. Make our lives easier. That's what a sample is. Sample small, population large. So why do we have to sample? Why can't they just ask every single person in the population? That's what a census is. A census is asking every single person in the population. What's an example of a census? I can think of one that we actually do here in this country.
Population census?
Well, yeah, it's a census. What's an example of a census? The election, sure. Every 10 years, doesn't our country conduct a nationwide census? Every 10 years, our Constitution requires that we take a census of the population, talking about how many people live within your household, how many people work, what are their ages. What are some problems with taking a census? Why is this maybe not the best strategy in figuring out what trends might exist within a given population? Sure. We may not hear from everyone. All right? If you think about that election, not everyone's going to vote. There are more people who don't vote than actually do. If I think about a census, what are some of the problems we might see with taking a census? What are some of the problems we run into when taking a census? I'm trying to ask every single person.
Not everyone's going to respond.
Yeah.
Yeah.
May not hear from everyone. Yep.
My bad.
Here plus, Chris.
Why does a census in our country only happen every 10 years?
To show the change.
Show change? Sure. Our population may change by the time the census is over. Takes a long time, right? How are we going to hit every single person in the population? If the population may change. Some people may pass away, some people may move away. So census only happens every 10 years because it's also really expensive.
Yeah.
It's time consuming, it's expensive. We're not guaranteed accurate results because, like you said, we may not hear from everybody. Our population may change throughout the lifespan of the census that we're trying to do. complete. Okay. So because we're not going to be doing a census, we're going to be pulling a sample of the given population. So we have different measures of center, spread, and a given value, a given proportion for a population and a sample. A parameter is just going to measure the center spread of a given group. And in math, we're not going to say population parameter, sample parameter. We're going to come up with different notation to model those given values. What's the notation we've used for mean before, the average? What's some notation we've used for the mean or average so far this year? X bar, Y bar. That is a sample parameter. That's the average of a given subset, a given sample from a population. We picked 10 cheeseburgers and we found the average fat content. So our sample is those 10 cheeseburgers and we calculated the average, the mean of that sample for our parameter. So when you see X bar, Y bar, that means it's the mean of our given sample. We haven't used the population parameter for mean very much. What is that? It starts with an M. Looks kind of funny. It's a Greek letter. It's a sound a cow makes, actually, too. U. U. It's an M with a tail on it. Did you say sigma, Emily? Sigma is actually one of the standard deviation parameters. Parameter is center, spread, and proportion. There's different notation for whether we're talking about a parameter value or a sample value, sample parameter. What's the notation we've used for standard deviation in the past? Emily said one of them. Sigma is the population standard deviation. The O with the curve coming off. Sigma denotes the standard deviation of a given population. What's another notation for standard deviation? One single letter.
Y hat.
That's going to come later. That's under proportion.
R.
S. S sub x, S sub y, that's the standard deviation of a given sample. Proportion parameter for the sample would be p hat. Or like you said, the y hat, same thing. It's a given value or a given proportion within a sample. Take the hat off and just call it p for the population parameter. There's more, but these are the ones that we'll probably use the most often. Okay, over on part 2, random. What does random mean? Random, random, random. If things are random. So, random.
It's not chosen on purpose.
If events are random, what do we know?
You
What does
can't
that
control
mean?
the outcome.
Can't control the outcome. Many different things can happen. We're not sure of what particular outcome it might actually happen. As humans, we can't think random. And if I asked you to write down 100 different numbers, you'd probably be using more number. You'd probably use one number more than any other. There'd be patterns in how you write down random digits. We can't think random. There's some bias in our random sample. We can work around that like we did earlier this week when we used random numbers to simulate randomness. Let's try and get rid of some bias. What bias is we're under or over-representing a particular group. If I ask you guys to write down 100 different random numbers, because we're all human, we'd probably have some numbers show up more than others. Some numbers show up less. You might be more inclined to pick 7 than you would versus 3. You'd be over-representing a 7, under-representing a 3. We're going to try and sample in such a way to get rid of as much bias as possible. Another important definition is sample variability. These are different changes we might see in a given sample. Sample variability happens naturally. And it's when our sample results differ because we're sampling different people or groups. Sample variability happens naturally. We might see different results in our sample, different outcomes in our sample because we're sampling different things. We can't ask everybody. We choose to ask a particular group. Because we're asking different groups in our samples, we might get different results. So think about some of the polls that just came out in our recent election. We had some polls that called for Kim Reynolds to win. We had some polls that called for Fred Hubbell to win. Why? Based on who took their survey, right? Because we were sampling different people within that survey, we can expect to see some variability, different results based off of who we're polling and how we're polling, right? There's some inherent bias because based off of who answers and how we take a sample, we're going to get different results based off of who are either under or over-representing within a given sample. What does sample size mean? Here on part 3. Sample size. Sample size. Sample size. How many people in a sample? How many people were polling or sampling? Surprisingly, this can be pretty small to get an accurate picture. We spend a lot of time second semester talking about different sample sizes and how that affects the outcome of what we're trying to predict. Surprisingly, we don't need a very large sample size to get an accurate prediction of any trends within a population. That's probably going to be about 4 weeks of second semester talking about the different effects of large and small sample sizes on different predictions within a population. Under sample size, what's important is the number of people we have to ask in a sample. Number of people, not the proportion or percent of the population. It's the number of people I sample that is important within the sample size, not the percent of the population. I don't have to ask 50% of the population in order to get a specific, an accurate prediction for my sample. What I do have to make sure I do is sample the appropriate number. And surprisingly, that can be pretty small to get an accurate prediction. More on that second semester. All right, let's swivel this around. Lastly, we've got 7 different types of sampling methods that we could use to get a representation of our population. Population big, sample small. What are the different ways that I can select a specific subset for my sample from a given population? These are the 7 different ways that we'll be studying. What are the differences? How are these conducted? Let's talk about that for a second. So simple random, one that we're probably all most familiar with. The most simple different way, the most simplified way to get a sample from a population. Everyone has an equally likely chance of being selected. Everyone has an equally likely chance of being selected. I put everyone in this class's name in a hat, I pick a name. We all have an equally likely chance of having our name drawn. That's a simple, random sample. Put everybody's names in a hat, pick a name out. There you go. Under stratified, we're going to break our population into groups. These are called strata. Each individual group is called a strata. And randomly choose people. Okay, so let's think of an example of this. Parking lot outside, it's the seniors who can park really close, is that right?
Most of us park really far away because we don't get it.
Yeah. Okay, fair. At my previous school, it was the seniors who could park in the first row. Okay? So if I did a simple random sample, and I just asked random people walking through the door, what was their opinion on seniors parking in the first row? Would I get an accurate picture of this? Exactly, right? It depends. So what's a better way to get an accurate picture of the different opinions on who's parked in the first row of the school? Well, let's break it into groups. What groups might I want to break it into? The grade level, right? The seniors probably have a different interpretation of how that's fair or not than any of the other grade levels. So the groups we're going to break it into is each grade level. Maybe we'll just ask 10 different people within each grade. Break into grades and ask 10. Generally speaking, a lot of different groups have different opinions, so we make sure we get an accurate picture by asking the same number of people within each group. Cluster and stratified are usually the ones that people get the most mixed up with. A cluster is just the complete opposite of what stratified sampling is. A cluster is we're going to break into groups, just like stratified. But then we ask everyone in a single group. I take the census of one single group. I ask all the seniors. I ask all the juniors. I ask all the freshmen in particular poll question. I poll all the freshmen. How do you feel about seniors parking in the front row? I ask all the seniors. How do you feel about all the seniors parking in the front row? That's what clustering is. Break into groups, but then we poll everyone. Next type of sampling is called systematic. Systematic means we invent a system to generate how we're going to poll different people. So maybe I ask every fourth person, every third person, every 10th person. I'm going to ask every 10th person who walks through the door. How do you feel about seniors parking in the front row? I camp outside the front door of school one morning. I ask every 10th person who walks through the front door. There's a system, there's a rule that determines which people get selected to provide a response or not. There's a rule to see who gets to be a part of my sample. That's what systematic means. Systematic sampling. Multi-stage means a combination of sampling methods. Maybe I do a multi-stage combination of stratified and systematic. I break into the grade levels. I ask every 5th person within a grade. Multi-stage, do more than one sampling strategy at a time. I break into grade level. I ask every 5th person within each grade. These first 5 are good methods of sampling. They're appropriate methods of sampling to try and get rid of as much bias as possible. The bottom 2 are not. Since we're just about out of time, voluntary. People choose whether they want to respond or not. What's an example of this? A voluntary sample. People choose whether they want to respond or not. Survey, online survey. Online. I put a poll about access to fresh water on the Iowa DNR website. Why is that probably a biased way of collecting information?
Only people that look at the Iowa DNR.
And they probably have a specific opinion one way or the other, right? Convenience. I ask only those people who are close by. Ask only those people who are near us. It's really easy. But I might not get the most diverse group of people. Yeah, it's easy to do, but who knows if these people are going to be generating a good picture of what's going on. We'll go over some more notes in class next week. Otherwise, have a great rest of your day.